We're speaking with Professor Avi Schroeder. We're here in his laboratory for targeted drug delivery and personalized medicine technology in the Faculty of Chemical Engineering. The reason we're here, Avi, Professor Schroeder, is because very often startups are based on science, and science becomes technology, and technology becomes commercial products and services that satisfy needs. And that's a difficult process. And by chance, not by chance, right next door is your startup. So we think you can tell us a lot, our learners, our students, about how science becomes wonderful innovations that make people happy. Professor Schroeder, give us a bit of your background.
First thing, Shlomo, good morning, and thank you very much for coming to us here at to the Department of Chemical Engineering at the Technion in Israel. Hosting you here is one of the most important things for us, is trying to spread the word that science can actually impact people's lives. Not only research, but research can realize into materials and new products that can change the way we enjoy life today, and can improve many aspects of our lives, either in medicine, in clean tech, in other regions of our lives. I was actually lucky. I had a very interesting training route. I started my training in the Ben Gurion University. I'm a chemical engineer by training. And chemical engineering may sound more like working in factories with huge chimneys, but not anymore. Chemical engineering today is about pharmaceuticals, it's about clean energy, and it's about new technologies for improving our daily life. I moved on after my first degree to continue in a master's and PhD combined between the Ben Gurion and Hebrew University. And I was lucky to work with two mentors, Professor Joseph Kost and Professor Yechezkel Barenholz from the Hebrew University, that had a lot of interest not only in inventing new technologies, but also bringing them or getting them to the patients. We were working on medical problems at the time, and I kept that line along my research, but we did have some interesting turns throughout my career.
We'll talk about those in a moment. But in your postdoctoral research, after you finished your PhD, you were at the famous Robert Langer Lab at MIT. That lab is famous for spinning off many startups and taking science into the marketplace. Tell us about the Langer Lab.
So Bob Langer, I think that's the essence of the Langer Lab, is an amazing person. He's an amazing scientist. He's a member of the 3 academies of National Science, but he's also the innovator, the inventor of many patents that realized into hundreds of companies around the world. A number I was told, I never actually measured it, is that the economy around the Langer Lab reaches around $19 billion annually, which means science is important, but we can actually start great and strong businesses around science too. And Bob Langer is actually the essence around that. It's realized science. That's the way I feel. Targeted drug delivery means we bring the medicine to where it's needed inside the body. We actually can use a zip code on these particles and address them to a specific region in our body or a specific disease tissue, and not anywhere else inside the human body. And that has huge advantages. And I think even people from outside the field can imagine what taking a drug without suffering the side effects would mean to their quality of life.
In a moment, we're going to take our camera and go next door to your startup. So let's share some of your insights with our learners about how science can become business. And maybe the best way to do this is to go back to your little liposomes, your little fat cells we've known about for 50 years, and talk about how this is becoming a business and some of the insights you have in turning liposomes into a business.
So I would say, I think there's several different criteria for trying and making business out of science. One is you really need to want it, right? You want to actually take your technology all the way from the bench to the patient's bedside. And the second criteria, I think, is the criteria of accepting surprise. And please allow me to share an example with you.
Yes.
So, working during my PhD studies, we were working on cancer medicines. And another physician came to us and actually recommended, she had this wonderful idea. She asked, you have these nice small balls full of medicine inside of them. Could we use them as ball bearings for reducing friction and wear in cartilage, in joints? We never thought of that concept. And we told her, this sounds like a very interesting problem to try and solve. Let's use these small balls and we'll inject them into patients' joints, diseased joints, and that way we'll reduce their pain, we'll help the joint regenerate. And she had in mind the joint of the jaw. She was an oral physician, and she had those joints in mind. And we actually thought of a different problem, knee problems, knee aches that so many adults actually suffer.
One second. So this is sometimes called lockjaw.
Absolutely.
Right?
Yeah.
And it's very painful, and it can be resolved by injecting these little ball bearings, fat cells, and it lubricates the joint, but you have to do this again and again.
So what we had in mind is that we'd inject it one time, and
Right.
we'd actually solve the problem. Not many people, though, suffer from lockjaw. People that suffer a lot. But when you do invent a new medicine, it has to impact the lives of many patients. If not, the large pharmaceutical companies who we want to actually continue our production won't be interested in this medicine.
Size of market is very important.
Size of market is key. So it's actually, I think, we don't believe anymore in huge blockbusters that will affect all patients. But we do believe in medium-sized blockbusters that can affect many, many patients,
Right.
millions of patients. And the number people used to quote is around a $1 billion market for your actual medicine, at least. If it's not that large, it will be very hard to convince the pharmaceutical companies to go and take this invention and work all the way on into getting it a product that will reach the market. Absolutely.
Mm-hmm. So this is what metamorphosed into something can help people's knee joints that need some lubrication, like mine. After 50 years of running, and the cartilage is a little weak, so these little ball bearings can be very helpful, and a lot of people have knee problems, knee pain.
Absolutely. So we're actually helping the first patients already. Shlomo, now I don't think you're actually enjoying our technology yet, but this may be the right time to go to the clinic and ask that from your physician. We are we started helping the first patients. And the path from the lab bench all the way to the patient's bedside wasn't that long. It actually, from conceiving the idea, 5 years later, we already had this technology helping patients' lives. And we waited a bit longer, and then we also had the results because we didn't know what was being injected to each of the patients. This is what's called a double-blind experiment, meaning we don't know what each patient is getting. And a bit longer we waited, and then we got the results that we changed these patients' quality of life. They were able to walk up and down stairs. They were able to get in and out of a bed. And their lives, which once were dictated by medicine and also by the physics of our world, now look normal or at least much better than they used to.
Let's summarize some of the insights here. You could have helped with lockjaw, but the market is small. Instead, you look for a more prevalent problem and a larger market because that determines commercial viability. The second lesson we learned is speed, 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 urgency. Get it out there. And here, we have a problem. In universities, we teach our students, our PhD students, perfection. Get it absolutely right before you submit your thesis. And in startups, urgency, get it out there. Minimum viable product, even for pharmaceutical products. So 5 years really is a short time. You clearly had this sense of urgency. But Avi, talk a bit about cultures. So you're a scientist, you're a researcher, you publish papers, but you also want people to use your findings, and that's a different culture, the culture of entrepreneurial startups. How do these cultures fit?
So I think there are actually several aspects that have to be addressed. One is you need an amazing team of people that work with you. Amazing meaning smartest people, probably even smarter than yourself, right? I mean, I want them smarter. My students, I want them to be smarter than I am, so they can think one step further, and they can, if we have a great idea, they'll always take it one step in addition, and I'll be there to support them. And so that's one aspect that has to be. And when you want to realize an idea, science has to be solid. You have to have strong science that can be repeated in the hands of any scientist around the world. If not, it probably will not work in a company. And that is one criteria we need for translating science from the bench to the bedside or into a company.
Strong science.
Strong science. You have to have the will to actually translate that science from the paper into a company. And that's something that some people share and some people don't. And I have no comments for those who don't want to realize their science. It's totally their choice, and I'm okay with that. But we do want. And I think the third aspect we have here in starting a company is now asking ourselves, wait, now it's becoming a business. This is about money. How do you make money from this science? Are we addressing the right problem? Are we economical? It may be our product is just too expensive and it won't reach the market. Are we answering a real pain clients have out there? Will the insurance companies, if we're talking in the field of medicine, insurance companies are key. Will they adapt our technology? Will the physicians adapt our technology? And we try to work with all these people very early on. We work with the regulatory bodies. Of course, we work with the physicians. We work with the patients. We try to ask the patients, what's your need? What do you suffer from? And then we try to put all that together. And sometimes we say, we don't have a good answer here. So starting a company around the bad technology is a waste of our time. And we don't have a lot of that around here.
So, Avi, Professor Schroeder, we're coming to the close of this interview. I'd like to ask you to share some of your key insights for our learners who may be thinking of starting a startup based on science. You've already shared a major one. Among the 10 tools in this course, I have a tool called Real Options. And Real Options says sometimes you try something that doesn't work, but it opens a window or a door. And if you hadn't tried to fail and failed, you wouldn't have found the window or the door, as, for example, your shrimp startup. What are some of your other key insights you'd like to share? We have thousands of learners all over the world who are thinking about starting businesses who already have.
Mm-hmm. I think one interesting approach we took here was to start the business inside the university. Meaning we can actually hire the best minds we have in the university and bring them over to this company right here. It also cuts cost in a major factor. Science companies need infrastructure like no other company that existed before. These infrastructures are actually available in the university for rent. So we're able to rent at a very low cost comparing to purchasing the newest scientific tools. So we have these scientific minds and we have the scientific tools and we have the people around it to actually support innovation. And I think that's one key factor. So startup companies need to keep in mind the budget they actually have in hand and how they're going to spend it. And always they need to remember that they'll have unknowns out there that they'll have to address throughout the way. So if everything is calculated and they're exactly on par with the amount of the investment they have, they'll probably have a problem a couple months from starting day because they'll face unexpected problems. And here we were able to actually keep some of the budget, put it aside for a rainy day. A rainy day meaning an experiment that didn't really work or a new regulatory rule that came out, and we do it right here. It's also an important message for me to pass to the students at Technion. And we show that science translates into new businesses. And that's what we want our great graduates to actually participate in, starting new businesses. And university is the best place for incubating a new idea, taking this concept, running a proof of concept at not a crazy cost, and then becoming a huge and impactful company.
So I'll add my own insight to yours. You mentioned incubation, incubators, and now they're called accelerators, and this is a global fashion. And I'm not a big fan of accelerators for many reasons, but I think you have created an alternative model here, which is a startup next door to a scientific lab. You have 5 startup entrepreneurs next door working in cramped quarters, but there are huge advantages, not just cost saving, but also being literally, physically right next to the science as it goes on. This model, I think, should spread because we need more startups right next to the science and benefiting from the synergy, benefiting from the infrastructure, saving money on expensive equipment, like the expensive instrument behind you. It looks like a Cadillac. So I think our learners should consider this as a possible model. Getting a room next door to a scientific lab where you take the science and you run with it to create great products.
Shlomo, absolutely. I think here my main partner is the Technion. The Technion values taking technologies and starting companies around these technologies. And the Technion here understood that had we not done it here in the Technion, this company may not have been as successful as it is. It may not be able to reach the milestones it needs without actually sitting right here. So we need an administration that understands that university doesn't span only throughout the 4 years of education that a student spends in academia. University has to also prepare them and maybe even start those companies our students will enter and begin working in. And I think it's a lifelong relationship. If we see university as our job is to generate ideas, run proof of concept, develop science, educate for science, but also prepare our students for working in the real world and also preparing the real world for tomorrow's technology. I think that's what we do here at the Technion, and we're doing it pretty well.
So we've now moved next door from Professor Schroeder's office or lab to his startup right next door. It's called Via Aqua, and we have the team here with us. We have Chen and the CEO of the company, Professor Shai Ofaz, and Adi. And I'd like to ask the CEO, Shai, how come you chose the really hard life of a startup entrepreneur? You're working here in cramped quarters, tackling a difficult problem. You could have had a quiet life as a bench scientist. You chose to be an entrepreneur. How come? Why?
Well, I'm a scientist and I like to practice science, but I prefer the practical side of science. And I think the most interesting thing to do when you would like to practice science is to start something from the beginning. It's the most interesting and the most enthusiastic, and it suits me the best.
Yes. You know, MIT, and Avi and I are very fond of MIT, has a Latin slogan, mens et mana, mind and hand. And that comes from 1865 when they started MIT, and that's created thousands of startups because graduates there think about science and breakthroughs, and then the manum, the hands, making it happen. Do any of the other team want to respond? Why are you becoming entrepreneurs?
Maybe Dr. Adi Baltau.
I think it's a passion that you have.
Passion.
Yeah.
So thank you all very, very much.